Hey guys, in this video we are going to talk about the open methods used in solving the roots of nonlinear equations. So for the bracketing methods discussed on our previous video, what we did was we assumed two initial values that bracket the root. Again, we made sure that the root is located within our interval. So the more we apply the algorithms presented, resulted in more accurate estimated value of our root. So bracketing methods are said to be convergent because they always move closer to the true value with every application or iteration of the algorithm. So in contrast, the open methods that will be discussed in this video requires only a single starting value, or two starting values that do not necessarily bracket the root. And because of this, there are cases where the open method may diverge or move away from the true value of the root. However, when the open methods converge, they usually do so much more quickly than bracketing methods. So again, in this video, yung pag-uusapan naman natin are the open methods. So the first open method that we are going to discuss is the fixed point iteration method. So fixed point iteration method is one of the open methods used to solve the root of an equation of the form f of x equal to 0. For this simple fixed point iteration method, also called one-point iteration or successive substitution method, so yung ginagawa dito is we develop a formula by rewriting the given equation in the form x equal to g of x. Now this transformation can easily be done by either algebraic manipulations or simply adding x to both sides of the original equation. So for example, here in our original equation f of x equal to 0, yung gagawin natin to transform it into x equal to g of x is we will simply add x to both sides of our equation here. So etong nasa left side, ito na yung g of x natin. So now we have successfully transformed our equation into x equal to g of x. Now if we substitute the solution or the root of our function here, we can see that our f of x will be reduced to 0. Therefore, we will be left with x equal to x. Again, yung left side natin dito, which is now x plus 0, so yan yung g of x natin. Okay? So, ibig sabihin, when x is the solution of f of x, then the left side and the right side of x equal to g of x are equal. Now, the first thing that we are going to do when performing the fixed point iteration method is we start by assuming an initial value for our solution. So let's say that is x sub o. And then the next thing that we are going to do is we will simply substitute our initial value into g of x. And then the value of g of x that is obtained is the new estimate for our solution. So ito na yung magiging second estimate natin. And after that, the second value is then substituted back into g of x, which then gives the third estimate of the solution. So yun lang yung gagawin natin sa fixed point iteration method. Assume tayo ng initial value for our x or for our root, and then we will just substitute that into our g of x. And then whatever the result of g of x, yun naman yung magiging new estimate natin. Ito na yung magiging itsura ng iteration formula na gagamitin natin sa fixed point iteration method. X sub I plus 1 equal to g of x sub I. As we have mentioned earlier, this method either converges to or diverges from the true value of the root. So when the method works, the values of x that are obtained are successive iterations that progressively converge toward the solution. So two such cases are illustrated graphically as shown. So here in our first graph, etong straight line na to, this will be the graph of the left side of our iteration formula. And then this one naman will be the curve of our function g of x. So yung point of intersection ng dalawang curves na to, yan yung true solution natin. Okay? Kasi again, recall that if we substitute the true solution to our iteration formula, the left side and then the right side will be equal. So again, yung ginagawa natin is we first assume an initial value. So ito yon. And then we substitute that or plug that into our g of x. Kung ano yung magiging value ng g of x na to, yan yung gagamitin natin for our next estimate. And then this new estimate is plugged back into our g of x. And then kung ano yung lalabas or ibibigay niya na sagot, yun naman yung magiging next estimate natin. So in this case, yung binibigay niya na values, again, converges towards the true solution. Similarly, here in our second graph, yung method natin also converges to our true solution. That is the graph of the left side of our iteration formula. And then itong curve naman na to, that is the graph of our g of x. Makikita natin dito na yung binibigay niya na values converges towards the true solution of our function. On the other hand, again, it is also possible for the iterations to not converge towards the fixed point, but rather diverge away. Okay? So, ito naman yung pinapakita ng dalawang graph natin dito. So, as we can see, the subsequent points or the subsequent values given by our iteration formula diverges away from our true solution. So, yung binibigay niya na value is papalayo instead na papunta doon sa true solution natin. In this case, yung method natin diverges. Similarly, here in our second graph, the values given by the iteration formula does not converge but rather diverge from our true solution. So, always keep that in mind, okay? Pag ginagamit natin is open method, meron talagang chance na mag-diverge yung mga values na nakukuha natin. Let's take a look at this example here. Determine the solution of f of x equal to x times e raised to 0.5 of x plus 1.2x minus 5 using fixed point iteration method for 10 iterations. So again, first thing that we need to do is we need to rewrite the given function into the form x equal to g of x. Now, take note that for a given equation f of x equal to 0, the iteration function is not unique since it is possible to change the equation into the form x equal to g of x in different ways. This means that several iteration functions can be written for the same equation. For example, here in our given equation, so one of the things that we can do to transform our function into x equal to g of x is we can factor x from the first two terms and then isolate x. So yung pwede din natin gawin is we can divide the whole equation by 1.2 and then itong second term natin, x na lang yung matitira. So yung gagawin natin is we will isolate that x. So we will have this equation. So pwede din natin gawin is we can isolate the first term and then divide the whole equation by e raised to 0.5 of x. So ito naman yung magiging resulta niya. Or what we can do is we can simply add x to both sides of our equation here. So we will now have this function. As you can see, napakaraming ways na pwede nating i-transform yung given equation or given function natin into our iteration formula, yung x equal to g of x. So again, x is nasa isang side and then we have a function of x on the other side. So ngayon, saan dito yung gagamitin natin na equation? Take note that there might be more than one form that can be used, or only one form will converge and then yung ibang forms naman will diverge. Or maybe that none of these forms are appropriate, ibig sabihin lahat sila will diverge. So if the iteration formula gives predictions that diverges from the true solution, then try to rewrite x equal to g of x in another form. In short, kahit saan dito yung pwede nating gamitan na equation. But take note that some of these forms might give us values that diverges away from our true solution. Okay, so just keep that in mind. So in this example, we will simply use the first form that we have obtained. And then let us start with an initial guess. So let's say our initial value for x is equal to 1. So we will simply substitute this value into g of x. And then, yung value na makukuha natin dito will be the value for our next estimate. And then, yung gagawin natin is we will substitute this back to g of x. And then, meron na naman tayong makukuha na value for our x. This will be our new estimate. And then, we will substitute this back to g of x. So, we will repeat this procedure 10 times, okay, because the problem asks for 10 iterations. And now, after 10 iterations, we have the value for our estimated solution, and that is equal to 1.504650. So again, yung pwede nyong gawin dito is you can try to use the other forms na na-formulate natin kanina and then apply the fixed point iteration method. So tingnan nyo kung magda-diverge ba or magko-converge din yung makukuha nyong mga values. So now, let us try to compare the value that we have obtained and then yung value na makukuha natin if we use the shift solve function of our scientific calculator. So ilalagay lang natin yung given function natin dito and then press shift solve, enter our initial guess which is equal to 1. And then, ito yung sagot na binigay niya. So, using the shift solve function of our calculator, we have x equal to 1.5049877762. As you can see, yung nakuha nating sagot using the fixed point iteration method is very, very, very close doon sa nakuhang sagot using shift solve in our calculator. Okay? Ibig sabihin itong sagot na nakuha natin is acceptable na siya. Okay, so next, we will take a look at another open method, which is the Newton-Raphson Method. So this method is the most widely used of all root locating formulas. So ito yung overview ng Newton-Raphson Method. So the solution process is medyo similar lang doon sa fixed point iteration method natin. So first, we assume a single value for our solution. So in this case, itong x sub I, ito yung magiging initial guess natin. So the second estimate, let's say x sub I plus 1, is obtained by taking the tangent line to f of x at the point x sub I, f of x sub I. And then finding the intersection point of this tangent line with the x-axis. So this point of intersection on the x-axis usually represents a better estimate of the root. So ito naman yung gagamitin natin for our next iteration. So the next estimate, x sub I plus 2, is the intersection of the tangent line to f of x at the point x sub I plus 1, f of x sub I plus 1 with the x-axis, and so on. So as we can see in our graph here, the method converges quickly towards our true solution. The Newton-Raphson method can be derived on the basis of this geometrical interpretation. So again, as shown in our figure, the first derivative at x sub I is equivalent to the slope. Recall na yung slope din natin is equal to rise over run. Tama? So, yung rise natin dito, that is equal to f of x sub I minus 0. And then, yung run naman natin, that will be equal to x sub I minus x sub I plus 1. So yung x sub I plus 1, ito yung new estimate natin. Isolating x sub I plus 1, we will have this function. So ito na ngayon yung tinatawag na Newton-Raphson formula. Our new estimate x sub I plus 1, that is equal to our previous estimate x sub I minus the value of our function at our previous estimate, so f of x sub I, and then divided by the first derivative of our function at our previous estimate, so that is f prime of x sub I. When using the Newton-Raphson method, kailangan natin kunin yung first derivative ng function natin with respect to x. Now, let us take a look at this example. Determine the solution of f of x equal to 1 over e raised to x minus x using the Newton-Raphson method and an initial guess of x sub 0 equal to 0. So, using the Newton-Raphson formula, kailangan muna nating kunin yung first derivative ng function natin. Okay, so f prime of x. So, from the given function, we can rewrite that as e raised to negative x minus x. And then yung first derivative nito with respect to x, that is equal to negative e raised to negative x minus 1. Therefore, yung Newton-Raphson formula natin will now have this form. Substitute lang natin yung f of x and then f prime of x functions natin. Ito na yung gagamitin natin for our iterations. Again, sabi ng problem, start with an initial guess of x equal to 0. So we will simply substitute 0 into our x here. And then that will give us the value for our next estimate. So our next estimate is equal to 0.5. Ngayon, ito naman yung ilalagay natin sa Newton-Raphson formula natin. Okay, so 0.5. And then that will give us the next estimate for our solution. And that is equal to 0.566311003. And then, ito naman yung isa-substitute ulit natin doon sa Newton-Raphson formula to obtain our next estimate. And then, ito naman yung isa-substitute ulit natin doon sa Newton-Raphson formula to obtain our next estimate. So this is equal to 0.567143290. Okay, so we can stop our iterations if we have satisfied the conditions given doon sa problem, if meron siyang condition na binigay. Or in this case, makikita natin na yung value ng new estimate natin is very, very close to our previous estimate. So you can solve for the relative error here, and then if you try to solve, yung relative error natin actually dito is very, very, very small na. So we can just stop here. So as we can see, the method rapidly converges on the true root. So after only 4 iterations, we have obtained an estimated solution for our function. Now if we try to compare that to the solution from our scientific calculator, so as you can see, equal lang yung dalawang values. Okay? Amazing. But then again, always keep in mind na itong Newton-Raphson method natin is an open method, so meron pa ring chance na mag-diverge siya. But if it converges, napakabilis naman. Okay, so napakabilis niya namang mag-converge towards the true solution. The last method that we are going to discuss is the secant method. So a potential problem in implementing the Newton-Raphson method is the evaluation of the derivative. So although this is not inconvenient for polynomials and many other functions, certain functions might have derivatives that are difficult or inconvenient to evaluate. So for these cases, we might have difficulty when using the Newton-Raphson method. So what we can do is we can use the secant method. This method is very similar to sa Newton-Raphson method. However, in this method, hindi na natin kailangang isolve or hanapin yung derivative ng given function natin. Instead, the derivative is approximated by a backward finite divided difference. So the value of our derivative is estimated by this equation. Now, if we substitute this equation to the Newton-Raphson formula, so yung f prime of x natin dito, ilalagay natin yung approximate niya given by the backward finite divided difference formula. So this equation is now the formula for the secant method. Again, makikita nyo dito, walang derivatives. Okay? So hindi na natin kailangang kunin yung derivative ng given function. So ito yung kagandahan ng secant method. Again, kasi merong mga formulas or function na minsan mahirap kunin yung derivatives niya. So this method, secant method, is easier to use than the Newton-Raphson method. So if you notice, this method or this formula requires two initial values or two initial estimates for our x sub I minus 1 and then x sub I. Yun yung kailangan natin to obtain the next estimate, x sub I plus 1. However, since this method is an open method, etong dalawang initial estimates natin, hindi na natin kailangang i-check kung na-bracket niya ba yung true solution natin. Kasi hindi naman siya bracketing method. Now, let us try to apply the secant method into this example. Determine a root of f of x equal to 7 sine of x times e raised to negative x minus 1 using the secant method with initial guess of x sub negative 1 equal to 0.3 and x sub 0 equal to 0.2. So again, yung kagandahan sa method na to, unlike the Newton-Raphson method, is we no longer need to obtain the first derivative of the function. So using the formula for the secant method, isa-substitute lang natin yung value ng dalawang initial guess natin. So meron ng binigay na initial guess doon sa problem. But in the case na walang binigay, kayo nang bahala. Okay? So kayo nang maglagay ng value for your two initial guesses. Now, in the secant method, kailangan din nating i-substitute yung value ng function natin at our two initial guesses. Okay, so we now have these values. We will simply substitute this to our secant formula. So, yung nakuha nating sagot is equal to 0.164813. Ibig sabihin, itong value na to, x sub 1, and then yung x sub 0 naman, yung gagamitin natin for our next iteration. So again, in order to obtain the value of our next estimate, yung gagamitin natin is yung x sub 1 and x sub 0. Kailangan din natin kunin yung value ng function natin, f of x sub 1 and f of x sub 0. So meron na tayong value ng f of x sub 0 kanina. After substituting these values doon sa secant formula natin, we now have our next estimate, which is equal to 0.170377. And then for our next estimate, x sub 3, yung gagamitin naman natin is yung last two estimates natin. So x sub 2 and then x sub 1. So now we have the value of 0.170181 for our estimated solution. So if we try to substitute this value to our function, makikita natin na it is very, very small na. So it is equal to 4.85 times 10 raised to negative 6. Almost 0 na yung value niya. Napakaliit na lang. So this means that the value that we have obtained is very, very close to our true solution. So again, as you can see, the method rapidly converges on the true root, like the Newton-Raphson method. So here, after only 3 iterations, yung value ng f of x natin is almost 0. Ibig sabihin, itong nakuha natin na estimated value for our root is very close to our true solution. Comparing this to the value that we can obtain from our scientific calculator, as you can see, these two values are very close to each other, no? So, almost equal na yung dalawang values ng x na nakuha natin. So, again, ito yung kagandahan ng open methods. When the method converges, very rapid or napakabilis niyang mag-converge doon sa true solution, unlike doon sa bracketing methods. Pero yung downside naman is yung open method, pwede siyang mag-diverge from our solution. So, instead na meron tayong makuhang sagot, wala tayong makuhang sagot if we use the open methods. So, always keep that in mind. Okay? Okay, so that's it for this video. Again, hopefully meron kayong natutunang bago. So, see you on the next one.